Question type 4, acetone-base neutralization. So let's have a look at this one. So we've got some aqueous sulfuric acid, 25 centimeters cubed of 0.150 concentration. So clearly, if I've given volume and concentration, it wants me to work out number of moles of sulfuric acid. So concentration 0.150 equals moles divided by 25 centimeters cubed is decimeter cubed is 0.025. So number of moles is 0.025 multiplied by 0.15. These two numbers together equal 0.00375. I've got the number of moles of sulfuric acid. I do the same for potassium hydroxide because I've been given a concentration 0.200, 0.2, and I multiply it by 0.03, which is 30 centimeters cubed is decimeter cubed. 30 centimeters cubed decimeter cubed divided by 1000 is 0.030. So I multiply those two together. I've got the number of moles of potassium hydroxide. Now what you've got to remember is sulfuric acid is a diprotic acid or a superacid. So 1 mole of sulfuric acid reacts with 2 moles of potassium hydroxide. So 2 moles of potassium hydroxide reacts with 1 mole of acid. So 0.006 moles of potassium hydroxide. If I divide that by 2, I work out the number of moles of sulfuric acid that I react with this amount of potassium hydroxide. 0.003 moles of sulfuric acid react with 0.006 moles of potassium hydroxide. So 0.003 moles of sulfuric acid reacting. I had 0.00375 moles of sulfuric acid to start with. So if I subtract the two, I work out that I've got 0.00075 moles of sulfuric acid left over. So I've got this amount of sulfuric acid in excess left over. But 1 mole of sulfuric acid makes 2 moles of H+. That's the nature of a diprotic acid or a superacid. It makes 2 moles of H+. So 0.00075 moles of the sulfuric acid, multiply it by 2, makes 0.0015 moles of H+. So I've multiplied that by 2 to get the number of moles of H+. Now, concentration of H+, concentration is the number of moles divided by volume. The new volume is 25 add 30, 55 centimeter cubed. Divide that by 1000 to get into decimeter cubed is 0.055. So the number of moles, 0.0015 moles, divided by the new volume as decimeter cubed, 55 centimeters cubed, or 0.055 decimeter cubed. Divide the two to get the concentration. Moles divided by volume. 0.0273 minus log to base 10 at 1.56. Does that seem like a reasonable pH for sulfuric acid? Yes, it does. Let's do the same thing again. Oh, we've got exactly the same kind of question here. So concentration and volume. So sulfuric acid, multiply those two numbers together. Remember to put this 0.264 into decimeter cube. 0.026 should be a 4 there. Never mind, it'll come out as approximately 0.0145 moles sulfuric acid. Do the same for the sodium hydroxide by multiplying these two together. You've got to convert that into decimeter cube. 0.0196. That's the number of moles of sodium hydroxide. This is a superacid, remember, so 1 mole of sulfuric acid reacts with 2 of these. Or in other words, I take this number, 0.141, and divide it by 2, and I work out the number of moles of sulfuric acid that would react with this number of moles, 0.0141 moles of sodium hydroxide. I know how much sulfuric acid reacts, 0.00705. Now, that's the amount of sulfuric acid that reacts, 0.00705. I had at the beginning 0.0145, so if I subtract the two numbers, I get the amount of sulfuric acid in excess left over, 0.0745. However, remember 1 mole of sulfuric acid makes 2 moles of H+. So I multiply this number of moles of sulfuric acid by 2, and it tells me I've made 0.0149 moles of H+. A new volume, 26.4 added to 19.6 is 46 centimeters cubed, or 0.046 decimeter cubed if we divide it by 1000. So I've got the moles of H+, I've got the volume of the solution, So concentration is moles, 0.00149 divided by 0.046, the new volume 0.324, that's my concentration of H+, minus log 10 it, 0.49. A very low pH, but that's okay. We've got a very strong acid, sulfuric acid, and it's a superacid diprotic acid, makes twice the number of moles of H+. Yeah, and it completely dissociates into H+. It's a strong acid, so that seems like a reasonable pH.